All right, well then let's go. So, you go through all of this stuff. Did this example feel okay? Yes. Okay. So at the end, you come to a p-value, and I will explain a little bit more details of our p-value. Okay. So if the p-value is small, we reject the null hypothesis, and we conclude the alternative is true, and we say we have evidence to support the alternative. Okay, HA being the alternative hypothesis. On the other hand, if the p-value is large, we do not reject the null hypothesis. Okay? And we would say we do not have evidence to support the alternative. Yes?
Does it always have to be one or the other of the hypotheses? It can't just like be neither of them?
No, it's either we reject the null or we do not reject the null. Okay? Note that I write do not reject the null. Okay? Do not write we accept the alternative. I mean, we accept the null. Okay? This would be wrong. Okay? You can accept the alternative, but you cannot accept the null hypothesis. I'm going to slide this up. I'll let you guys keep writing it down. So here's the definition of the p-value. The p-value is the probability of observing our data for something more extreme if we assume our null hypothesis is true. So it's not the probability that the null hypothesis is true. It's the probability of observing our data, or something more extreme, if we assumed the null hypothesis were true. Should be work. So we accept. How do we decide when our p-value is large or small? Okay. So somewhere in the problem, it will either provide you with a significance level or something called alpha. Significance level is equal to this alpha. Okay. The most common level, or most common value is alpha equal to 0.05. But we can use larger values or smaller values of alpha, okay? If the significance level is not specified in a problem, assume that it's 0.05. So that if p-value is greater than or equal to alpha, we say the p-value is large. Okay, and what is our conclusion when the p-value is large? We do not reject the null. Okay? We do not reject the null. We do not have evidence to support the alternative. Is that okay? And then on the flip side, if the p-value is less than alpha, what do? We say the p-value is small. And that means we reject the null hypothesis.
There's actually a desk out in the hallway there.
There is.
Just got,
Give me a second here. This is tough. Alright, okay, so if we say the p-value is small, we reject the null hypothesis. Okay. And And that's what we've got going on there. Okay, so let me talk about our hypotheses. So at the very beginning of the problem, we write our hypotheses. Okay. The null hypothesis always has an equal sign. Okay. And in chapter 8, when we're dealing with one sample, okay, so for one sample proportion in chapter 8, the null hypothesis will be something like P is equal to whatever, 0.35. I'm just making that 0.35 up, okay? Depends on what the problem says. The alternative HA will have not equal or greater than or less than, okay? And your choice depends on how the question is written. Okay, not equal, this means we have a two-tail or two-sided test. Two-tailed test, and the question will say things like, is different, has changed, not the same. Things along that line, okay? And then when you have a two-tailed test, your p-value is equal to 2 times the tail area, okay? So you look up your z-score and you get a tail area. Your p-value will be 2 times that. Over here, these are a one-tailed test. Okay. The questions will say things like larger or smaller. Alright, and so you have to choose greater than or less than appropriately, okay? You know, more or less, etc., etc., etc. Things like that. Things along that line. And in these problems, the p-value will equal the tail area, okay? Generally, alright? So for HA with greater than, take the area to the right. And for HA with less than, take the area to the left. generally, that means the p-value will be equal to the tail area. But there's a chance that you get a problem with the wrong direction. Alright, so I'm going to keep going here, and we'll cover the next topic in Chapter 8, and this is hypothesis tests for proportions from two samples. So we will, I'll go over this, and then we'll do an example. Okay. So in this case, we have two samples, and we want to know if the samples are the same or if they're different. Okay. I mean, if the samples have the same proportion, or if the proportions are different. Okay. So it could be, maybe we look at men and women, and we say what percentage of men drive trucks and what percentage of women drive trucks. Okay? Is the proportion or percentage of men and women who drive trucks the same, or is it different according to gender? Okay? Or it could be something like I don't know, you have two groups of people. Maybe you have you go to a high school and you look at 11th graders and 12th graders, so juniors and seniors. And then you could say what percentage of juniors have their driver's license versus what percentage of seniors have their driver's license. Is the percentage the same, or is it different? Okay. So you're looking at two samples, and you're asking, is the percentage in those two samples the same, or is the percentage different? Two samples, and when we ask, it's actually not if the samples in the, not the percentages in the samples, but the percentages in the corresponding populations. Okay. If the samples provide evidence that the proportions in the corresponding same or different. So in this case, our null hypothesis would be that P1 equals P2, meaning the proportion in population 1 is the same or equal to the proportion in population 2. Right. This could also be written P1 minus P2 equals 0. If they are saying the same thing. This one says the two numbers are equal to each other. This one says that there's no difference between the two. the alternative can be P1 is greater than P2, or P1 is less than P2, or P1 does not equal P2. And this depends on how the question is written. Okay? Alternatively, it can be rewritten as okay. We calculate our test statistic. Okay. This involves finding the standard error and the z-score. Okay. The standard error is going to be an ugly number, and there's nothing we can do about it. All right. It's an ugly formula. Nothing we can do about that. It's going to be p hat times 1 minus p hat divided by 1 over n1 plus 1 over n2, okay? And it gets worse because p hat has its own formula. This p hat is x1 plus x2 over the quantity n1 plus n2. I promise it's not so bad, okay? Or it's just an ugly formula. There's nothing we can do. We just have to deal with it. Once you accept that this is your life now, it will be okay, alright?
I didn't picture this for my life.
Yeah, I know. Well, just this phase. You only have 3 more weeks of it, okay? I have it for a lot longer than you, okay? Until I retire, probably. And I love this stuff, right? So this is, I get to spend my birthday going over teaching the stuff I love to people I love.
Yeah. Love you too.
So
Let's take you up for a round of drinks, Rebecca.
huh?
Let's take you up for a round of drinks.
I'm here for you.
You can buy me drinks and a Big Mac, right?
Yeah,
Let's
look at
go get
O'Hara's
a
over
Marie
here.
right now. Hey, I'd be so down.
There's something a little strange about how much joy this brings you. But that's okay. Probably there's something strange about how much joy this statistics brings me. So that's how we get our standard error. We will do all of this with actual numbers, and I hope it makes more sense when we do it, okay? And then, so once we get our standard error, we go in and we find our z-score. And so our z-score is going to be p1 hat minus p2 hat. And there's technically a minus 0, but minus 0 does nothing, so we can pretty much ignore it. Divided by the standard error, okay? Because it's supposed to be our observed difference minus our expected difference, okay? And the expected difference under the null hypothesis is 0, okay? But
So in other situations, we would have a number there, but not in this class. Would we ever have
I would say in 90% of your situations, your expected difference is going to be 0.
Okay.
Yeah, and in our class, it's always going to be 0. Okay, so let me just also, I will write that our observed difference between sample proportions is equal to P1 hat minus P2 hat. So that's, we get our z-score, then we look it up in our table to get our tail area, okay? again, all of those rules that I went over just a few minutes ago regarding whether you double your tail area for to get your p-value or you leave it the same, that all applies here. Okay. So I will let you write this down, and then we will do an example. We'll do a few examples, just to make sure we got this, and then we can go home. Huh? I said after we do a few examples. Oh, so does someone have a sheet of paper? We'll do a attendance audit for you guys, all right? So, yeah, so let me just get a quick head count. 1, 2, 3, 4.
That's funny.
It's like a percentage of your grade.
Okay, so it is a percentage of your grade, but it's like free points. If you're here, you get it, okay?
It's like an extra like 5%.
It accounts for 5%, yeah.
Professor, can you hold on? I need to get the phone over the way. Hold on.
Okay, okay.
So we had 2 attendance audits, and both of those combined is 5%, right? Or each is 5%?
No, total, all the attendance audits and homework audits combined will be 5%.
Okay, let's see. You get both homework points. You get both homework points.
Alright, I'll leave this formula up here,
Okay.
and I will,
If you're here the 2 times you did it, that's an extra 5%.
alright, so let's say, we go to a high school, and, we take a random sample of 50 seniors and let's say 45 juniors. Okay? And we ask, are you going to prom? Does everyone go to prom or no?
No, I went to my.
What's that? Is this a terrible question? Alright, okay, just so we don't violate our large sample conditions and stuff, let's make sure. So we will say 40 seniors say yes. And 33 juniors say yes. I'll change that to, let's say 31. 31 juniors say yes. So, do we have evidence that more seniors, that a greater percentage of seniors go to prom than juniors? Okay, does that make sense? So we took a random sample of 50 seniors and 40 of them said yes, they're going to prom. And then we took a random sample of 45 juniors and 31 of them said yes, they're going to prom. Is this evidence that more seniors go to prom than juniors, or a greater percentage of seniors go to prom than juniors. Okay? Does this question make sense? We're good? Okay, so what would my hypotheses be? My null hypothesis would be that the proportions are equal, right? Or that there's no difference between the proportions. So I could say P1 minus P2 equals 0. P1 will be seniors going to prom. And P2 will be juniors going to prom. I should write proportion. Proportion of seniors going to prom, and P2 will be the proportion of juniors going to prom. Okay? So my question says, do we have evidence that a greater percentage of seniors go to prom than juniors? So what would my alternative hypothesis be? Yes, I would write P1 minus P2. Should this be not equal to 0, greater than 0, or less than 0? Greater than 0, because we're expecting more seniors than juniors going to prom. Okay. So these are my hypotheses. What is my data? How big is my N1? 50. This is the number of seniors that I have. How big is my N2? 45, okay? How many people, how many seniors are going to prom? So X1 is 40. And how many juniors are you going to prom? 31, okay. So what is my proportion P1 have? 40 over 50, I have 0.8. What is my P2 hat? 31 over 45. I need a calculator for this. 0.68. 0.68?
I forgot. I didn't even write it down.
Yeah. 0.688. Or 0.689. Okay? So far, so good? Okay, I'll let everybody write all of this down. Okay? So as you do your problems, if you do it this way, do your hypotheses, and then list out your data, okay? Just take a moment to say, label, this is N, and this is X, and this is my P hat, and all of this. If you take a moment to do that with your data, the rest of your problem will be easier, okay? Some people try immediately going to the formula and sticking numbers in. That's a good way to confuse yourself.
Great way to confuse yourself.
So.
How'd you get the 45 again?
I just, it's from, written in the problem, okay? 50 seniors and 45 juniors. So it's how many in my second sample do I have? So we want to know, do the same proportion of juniors and seniors go to prom? If the proportion was the same, we would expect both numbers to be the same. But what we see is that 80% of seniors are going and about 69% of juniors are going. Is that evidence that the proportions are different? Or could this difference that we observe just be a result of random chance? That if we took another sample of juniors and seniors, the proportions would be closer to the same or something like that. That's what we want to know. Okay, so let's work on figuring out our test statistic, okay? It says our standard error is this, okay? But first, we got to figure out what P hat is. So P hat is X1 plus X2 divided by N1 plus N2. So I have 40 plus 31 divided by 50 plus 45. So on the top I have 71 divided by 95. So my p hat is 0.7474. And we're going to use this to get my standard error. Standard error is p hat times 1 minus p hat, 1 over n1 plus 1 over n2. 0.7474 times 1 minus 0.7474 times 1 over 50 plus 1 over 45. Bless you. Right, yeah. So do I get 0.0893. Okay. Some of you will have calculator problems. Unfortunately, I can't answer all of your calculator problems. If you have calculator issues, you can come see me. I'll try to get you sorted out. Okay? But if you do this, we should get 0.0893. Okay, you take the square root, you get 0.0893. Okay? You might come really close, off by a tiny bit because of rounding or something. That's fine, no problem. Okay? But this is how I get my standard error. Is that okay?
Yes.
Great.
Wait.
Wait, who said wait?
Can I still
Yes, you may finish writing. And you add those two together and you multiply by everything. Yes?
Is this like an example of something that we have in our next quiz / final?
Yes.
Just like just to find the standard error, but like.
Well, not just finding the standard error, okay? It's all part of the problem, okay?
Are there more steps after this?
Yes. So once we find the standard error, we have to find our z-score, okay? So we said our z-score. Great. Okay. Our z-score is our observed difference, p1 hat minus p2 hat, technically minus 0, divided by our standard error. Okay. So p1 hat is 0.8 minus p2 hat 0.689 divided by my standard error 0.0893.
Are we only gonna have one of these problems on our test?
Nice.
Kind of really long.
It is kind of really long, okay? So your quiz will probably have two problems, okay?
Oh my god.
Maybe 3 problems.
More than 30 minutes.
Maybe 5. I know. No. Your quiz will probably have 3 problems, and I'll break it down. It'll be like, here's the problem. Part 1, what are the hypotheses? Part 2, what is your p hat? Part 3, what's your standard error? Part 4, your, you know, stuff like that.
So
What?
it's technically
It's like one problem divided into 5 or 6 parts. And you'll probably have 2 or 3 of those. It's like a lot of fun. Okay.
This is like a longer version of the standard deviation.
It's not too bad. Okay. So anyway, we do this, and I get a z-score of 1.24 or something like that. Okay. So I have a z-score of 1.24. Am I done?
No.
No. What do I do now?
Table.
I go to my table, and I go to 1.24, and what part am I finding? The area to the left or to the right? To the right, okay? So, when you have the greater than, you're going to the right, or in most cases, you'll generally find the tail area, the side away from the hill. Okay. So when I do that, I look up 1.24, and I get 0.8925, which means that over here I have 0.1075. Okay. 0.1075. What do we call that? This is my tail area. Do I leave it as is or do I double it to get my p-value?
Double.
What is the rule?
It has to be like
So
something
if
different.
you to decide whether we leave it as is or double it, we look at our alternative hypothesis. If the alternative hypothesis has a not equal sign, I double it. If it has a greater than or a less than sign, I leave it. So in this case, what am I going to do? I'm going to leave it. So my p-value is equal to 0.1075.
Can you say it again?
Huh?
Can you say it again?
Say what again?
For the doubling thing.
Okay, so it should already be in your notes. It should already be in your notes, but I'll say it again. Whether we double or not depends on my alternative hypothesis. If this has a not equal sign, okay, not equal sign means double the tail. Okay? Greater than or less than, leave the tail. As is. And it all depends on the alternative. The null hypothesis always has an equal sign, so we can't look at that. Yes? When we have two tails, when we have a not equal sign, okay? All right, that's. All right, great. So my p-value is 0.1075. Let's say my significance level, I know, it's a lot to take in, but let's say my significance level is 0.05. Okay, so somewhere in the problem it says significance level is 0.05. What do I do with my p-value and significance level? Okay, so I compare the two. I compare my p-value to the significance level, and what I see is that my p-value is bigger than the significance level. You see that? 0.1075 is bigger than 0.05. So my p-value, I would say, is greater than alpha. Significance level is also called alpha. So my p-value is greater than alpha. So what is my conclusion? When your p-value is greater than alpha, that means we do not reject the null hypothesis. P-value is greater than alpha means we do not reject the null hypothesis. Okay, so we do not have evidence that more seniors attend prom, that a greater percentage of seniors attend prom than juniors. Is that okay?
Yeah.
Yes.
Are we doing another one of these, or is it?
Huh?
It took us 15 minutes to do that.
Yeah, I could do one more. You,
We're
Not
good.
on the quiz, we only have to do 2 problems, because there are the dedicated questions.
well, I
And that's
was
when it
talking
extends
and
for-
explaining everything here.
Well, we're
so
thinking.
fine. Get through it all. Okay.
They get an even number, so fine.
Huh?
Wait, what, we're getting extra quiz time?
I don't. Why are people saying these things? Okay. So this says we do not have evidence that a greater percentage of seniors attend prom than juniors. Does that mean the same percentage of seniors attend prom as juniors?
No.
No, it just means that when I took a sample of 50 seniors and 45 juniors and got this, that's not enough data to say more seniors go than juniors. If we surveyed the whole school or we got a very big sample, maybe we will find evidence that more seniors go than juniors, okay? But just like at the casino, after playing only 10 games and winning 70%, that's not enough for them to conclude that I'm cheating. But after playing 100 games or a lot more and still seeing 70%, that's enough to come to the conclusion that someone's cheating, okay? Okay, well, if you really don't want to see any more examples, I guess we can end there, all right? Have a good night.
Happy birthday!
And I'll have a happy birthday, all right? Okay.
Mom,